Hello everyone. In this video we are going to learn how to construct binary search tree and how to delete an element from that binary search tree. Insertion is very simple, but deletion have some difficulties, like total 3 conditions are there. If there is one node, then if there is a leaf node, how to delete. If there is a node which have only one children, how to delete that particular node, and the node which have two children, how to delete that particular node. Okay, and also we solve this example that was asked in GTU examination, that so that the resultant BST after applying the following operation in sequence on a given tree. This is a tree. Delete 8, insert 9 and delete 7. Okay, so first we see how to construct binary search tree. After binary search tree, find the preorder, inorder and postorder traversal that I already I already make this video for inorder, preorder and postorder. Please check the data structure playlist. Okay, in this video we are find the inorder, preorder, postorder by shortcut method only. Okay, so let's start. So what is binary search tree? So it's a tree in which each node possessed a key that satisfies the following condition. The left subtree of a node has elements with the values lower than the values of the node, and the right subtree of a node has elements with values greater than the values of the node. Okay, both the right and left subtrees should be binary search tree. Okay, so binary search tree is a data structure that is commonly used to implement efficient searching, insertion and deletion operations. Okay, so the key features of BST is that it is a binary tree where each node has at most 2 child nodes. Okay, किसी भी नोड के 2 से ज्यादा चाइल्ड नहीं हो सकते. एक होगा चलेगा, 0 होगा चलेगा. Is it clear? And the value of each node is greater than the value in its left subtree and less than all the values in its right subtree. This means that the left subtree of a node contains the values that are smaller than the node's value, and the right subtree contains values that are larger. Okay, so due to this property, binary search tree allows for efficient searching by repeatedly dividing the search space in half, which makes it an important data structure in computer science and many other fields. Okay, now we see how to create a binary search tree. Okay, suppose you are given the data that 50, 25, 75, 22, 40, 60, 80, 90, 15 and 30. So how to create a binary search tree? So the first node is always your root node. Okay, now next element is 25, which is less than 50. We have to compare with each and every node. Okay, right now I have only one node, so I will compare 25 with 50, which is less than 50, so it will be at the left of the 50. Okay, now next element is 75. 75 will compare with the root node first. 75 is greater than 50, so it will be at the right hand side of the 50. Now the most important thing that student always do, that 22, suppose the next element is 22, so it is less than 50, so don't draw here, because what is the one of the property of binary search tree, that each and every node has at the most 2 child. 2 से ज्यादा children नहीं हो सकते. एक होगा तो भी चलेगा, 0 होगा तो भी चलेगा. So this 25 will be first compare. पहले हम किससे कंपेयर करेंगे? 50 से. 50 से लेस है तो हम कहाँ गए? लेफ्ट हैंड साइड. फिर अब नेक्स्ट दैट इज 25. 25 से कंपेयर करेंगे 22 को. 22 इज लेस देन 25, so it will be at the left of the 25. अब आप शायद सोचेंगे सर लेफ्ट ईयर में रखे या राइट में रखे, क्या प्रॉब्लम क्या आएगा? व्हेन यू फाइंड द इन ऑर्डर, प्री ऑर्डर, पोस्ट ऑर्डर, that creates a problem and your binary search tree will be not accurate. So it must be, you must have to following that precondition. If it is less, then you have to put at the left hand side. अगर particular node से higher element है तो right hand side, और आपका जो लेफ्ट सब ट्री बनता है दैट इज ऑल्सो अ बाइनरी सर्च ट्री। ओके, उसके भी एक से दो से ज्यादा नोड्स नहीं होने चाहिए, दो से ज्यादा चिल्ड्रंस नहीं होने चाहिए। ओके, सो नेक्स्ट नोड इज 40। 40 is greater than less than 50, so go to the left। ओके, 25 से वेरीफाई चेक करो, 40 is greater than 25, so 40 will be at the right of this 25। clear? Because there is a null pointer here, every element every node has, just 1 minute, suppose this is 50। okay, every node has total 2 pointers, first one is left pointer, second one is right pointer। okay, so 25 have one null pointer at the right hand side, and what we have to insert, we have to insert 40, so 40 is greater than 25, so it is at the right of this 25। clear? So next element is 60। now 60 is greater than 50। okay, so it must goes on the right subtree। now we have to check with 75। 60 is less than 75, so it is at the left of this 75। similarly 80। 80 is greater than 50, go to right। 80 is greater than 75, go to right hand side। okay, next element is 90। 90 is greater than 50, go to right। 90 is greater than 75, go to right। 90 is greater than 80, so 90 will be at the right of 80। next element is 15। 15 is less than 50, go to here, check with 25। 15 is less than 25, go here left hand side, check with 22। 15 is less than 22, so 15 will be at the left point, left at 22। okay, it's a left of 22। next one is 30। 30 is less than 50, go to left। 30 is greater than 25, go to right। okay, now check with 40, that 30 is less than 40, so you have to mark at the left of the 40। so each and every time you have to compare that particular node with the root node, then it's left subtree or right subtree। okay, so this is how we are going we are creating a binary search tree। it is very simple, but how to delete a particular element, what are the criteria that are difficult। let's solve one of the problem which are asked in GTO examination। construct binary search tree for the following data and find its in-order, pre-order and post-order traversal। okay, if only binary search tree will be asked, then it will be of 3 marks। okay, but jointly they asked find its in-order, pre-order and post-order, then it will be of 7 marks। okay, so constructing a binary search tree is simple। okay, but finding in-order, post-order, pre-order have some algorithm, you have to learn that algorithm also। in this video I will explain you with the help of shortcut method, huh? so please understand and watch the video which is in the data structure playlist, that how to find in-order, pre-order and post-order with the help of algorithm। okay, okay, as usual, so first node is our root node, then 3 is less than 10, so it is in the left of 10। next 15, 15 is greater than 10, so it is at the right of 10। okay, next element is 22। 22 is greater than 10, go to right। now check with 15। 22 is greater than 15, so we have to put it at left of the 15। clear? now 6 is less than 10, go here। 6 is greater than 3, so 6 will be at the right of this 3। next one is 45। 45 is greater than 10, greater than 15, greater than 22, so it is at the right of 22। next 65 is greater than 10, greater than 15, greater than 22, greater than 45. So it will be at the right of 45. Next element 23. 23 is greater than 10, greater than 15, greater than 22, but less than 45. Okay, so it will be at the left of 45. Next element is 78. Compare with root node. It is greater than 10, go to right, greater than 15, go to right, greater than 22, greater than 45, greater than 65. So 78 is at the right of 65. Next one is 34. 34 is greater than 10, 15, 22, but less than 45. Go to left, greater than 23. So 34 is at the right of 23. And the last element is 5, which is less than 10. So we go to the left subtree, check with the node, that is 3. 5 is greater than 3, go to right, check with 6. 5 is less than 6, so 5 will be at the left of this 6. Okay, so we construct the binary search tree. Now we find its in-order, pre-order and post-order traversal with the shortcut method. Okay, for finding the pre-order, in-order and post-order, there is one simple trick. You simply have to mark at the left, at the right of the node, and in the middle of the node. Okay, so ध्यान क्या रखना है आपको? ध्यान ये रखना है, अगर राइट चाइल्ड है तो राइट मार्क और मिडल मार्क के बीच में आना चाहिए. अगर लेफ्ट चाइल्ड है तो लेफ्ट एंड ये इन ऑर्डर का जो हमने मार्क डाउन किया है उसके बीच में आना चाहिए. फॉर एग्जांपल हियर यू कैन सी लेफ्ट चाइल्ड है तो इन और प्री के बीच में आ रहा है. अगर राइट चाइल्ड है तो पोस्ट एंड इन के बीच में से ही वो क्रॉस होना चाहिए. ओके, इज इट क्लियर? सो दिस marker indicates the pre-order, this marker indicates the in-order, and this marker indicates the post-order. Whenever we reach at this marker, we write it down in the pre-order. We reached in the in-order, we have to write it down in in-order. When we reach in this marker, then we have to write at the post-order that particular number. Let's see. So always we have to start with the root node. Okay, from here, and go to top to down and left to right manner in like in depth first search. Okay, so first element is 10. This line that indicates the pre-order, so write it down 10 in pre-order, just like this. Okay, then go as a DFS. Which line touches first? Pre-order, so write it down 3 in pre-order. Write it down 3 in order because this line indicates in order. Write it down 6 in pre-order. Write it down 5 in pre-order. Write it down 5 in order as well as post-order. Okay. Next, write it down 6 in order, 6 in post-order, 3 in post-order, 10 in order, and 15 in pre-order, 15 in order, 22 in pre-order, 22 in order, 45 in pre-order, 23 as pre-order, 23 in order, 34 in pre-order, in-order 34, post-order 34, post-order 23, in-order 45, pre-order 65, in-order 65, pre-order 78, in-order 78, post-order 78, post-order 65, post-order 45, post-order 22, post-order 15, and last post-order 10. So it's a shortcut method how to find the pre-order, post-order and in-order. So it will consumes less amount of time compared to always you are going to check with the root, left, right. Okay. So let's see now how to delete an element in the binary search tree. Okay. Okay. So constructing a binary search tree is very simple. Okay. अगर लेफ्ट रूट नोड से स्मॉलर एलिमेंट आता है तो उसे लेफ्ट हैंड साइड पे रखो और रूट से अगर ग्रेटर एलिमेंट आता है तो राइट हैंड साइड पे रखो. ओके. बट हाउ टू डिलीट एन एलिमेंट फ्रॉम द बाइनरी सर्च ट्री? सो टोटल 3 केसेस हैं जो आपको ध्यान में रखना है. फर्स्ट केस इज नोड टू बी डिलीटेड इज अ लीफ नोड. डायरेक्टली डिलीट द नोड फ्रॉम द ट्री. लीफ नोड आपके कौन से नोड होंगे? जो एट द लास्ट में होंगे. अगर इसकी बात करूं मैं ये ट्री की, तो 8 इज अ लीफ नोड, 11 इज अ लीफ नोड, सॉरी एंड 18 इज अ लीफ नोड. इज इट क्लियर? अगर लीफ नोड पे है आपका नोड जिसे आपको डिलीट करना है तो सिंपली डिलीट इट. फॉर एग्जांपल यहां पे हम अगर डिलीट 5 करना है तो हमने क्या किया? 7 के लेफ्ट से 5 को हटा दिया. दैट्स इट. इट्स वेरी सिंपल. अगर वो लेफ्ट में आता हो या राइट में आता हो, अगर वो लीफ नोड है simply delete it. Okay. Next condition is node to be deleted is an internal node with one child. For this case, delete the node and move its child up to take its place. Simple. कौन से केस हो सकते हैं? एक केस हो सकता है कि ये नोड है, this is another node, this is another node. Internal node means अगर हमें B को डिलीट करना है, this is B, this is C. Okay, if you want to delete this C, we directly delete. That is case number 1. What is case number 2? How to delete internal node? अगर इस internal node को हम delete करते हैं, that is B, then we have to simply move up this C. That's it. Okay, तो C कहाँ चला जाएगा? Suppose this is A. C is not at the right hand side of A, हाँ? C simply कहाँ आ जाएगा? यहाँ. Simple. ओके. अगर C के नीचे भी और कोई चिल्ड्रन होता तो वो भी उसके साथ अटैच रहेंगे. इज इट क्लियर? ओके. सपोज वी हैव टू डिलीट 15, दिस 15. सो जितने भी चाइल्ड होंगे 15 के, सिंपली वी हैव टू मूव अप. उसका फर्स्ट चाइल्ड कौन है? इमीडिएट चाइल्ड इज 11. सो वी सिंपली हैव टू मूव 11 इंस्टेड ऑफ 15. यू कैन सी हियर. राइट हैंड साइड पे क्यों रखा, लेफ्ट हैंड साइड पे क्यों नहीं? ओके, बिकॉज this 11 is at the right hand side of this 10 and obviously 11 is greater than 10. Okay, so it must be at the right hand side of the 10. So simply you have to replace 15 as 11 and delete this 15. Okay, and the most important condition is case number 3. So what case number 3 says? Node to be deleted is an internal node with 2 children. Okay, this case is only somewhat complicated. First and second case तो बहुत सिंपल था. Okay, अगर कोई नोड ऐसा हो जिसके 2 चिल्ड्रंस हो, फॉर एग्जांपल यहाँ पे 15 के 2 चिल्ड्रन है, फॉर एग्जांपल यहाँ 10 के 2 चिल्ड्रन है. अगर 10 को डिलीट करना है तो क्या करना होगा? 15 को डिलीट करना है तो क्या करना होगा? क्लियर? Copy the content of in-order successor. Successor means in-order. For example, successor of 10 is 11. Successor of predecessor of 10 is 8. Okay. Successor of 10 is 11. Predecessor of 10 is 8. Similarly, successor of 15 is 18. Successor of predecessor of 15 is this 11. Clear? So copy the content of the in-order successor of the node to be deleted and delete the in-order successor. अब ये थोड़ा कॉम्प्लिकेटेड हो गया आपके लिए. सर ये कैसे होगा? कौन फिर एग्जाम में in-order पहले फाइंड आउट करने जाए और उसके बाद डिलीट करने जाए? ओके, आई हैव सम सिंपल ट्रिक ऑल्सो, देख लो. The in-order successor can be found by finding the minimum element in the right subtree of the node. For example, अगर मुझे 10 डिलीट करना है, this is case number 3 which have total 2 children. Okay, right now the left child is 7 and the right child is 15. अगर in order successor को हम अप्लाई करते हैं डिलीट करने के समय, तो सिंपली राइट हैंड साइड पे सबसे स्मॉलेस्ट एलिमेंट कौन सा है? 11 है. ये पूरे राइट सब ट्री में सबसे स्मॉलेस्ट एलिमेंट कौन है? 11 है. तो सिंपली वी हैव टू रिप्लेस 11 विथ 10. दैट्स इट. ओके, 11 यहां से हटके कहां आ जाएगा? हियर. एंड ऑल्सो यू कैन सी द प्रॉपर्टी ऑफ बाइनरी सर्च ट्री इज मैच दैट 11 के लेफ्ट हैंड साइड पे सारे स्मॉलेस्ट एलिमेंट होने चाहिए, 11 के राइट हैंड साइड पे सारे ग्रेटेस्ट एलिमेंट होने चाहिए. 15 एंड 18 इज ग्रेटर देन 11. इज इट क्लियर? नाउ आप बोलोगे सर ये प्रीडिसेसर और सक्सेसर क्या है? गेट एग्जाम में, आई एम टॉकिंग अबाउट गेट एग्जामिनेशन, लाइक उन्होंने अगर कहा कि इन ऑर्डर प्रीडिसेसर यू हैव टू फॉलो फॉर डिलीटिंग 10, तो सिंपली क्या करना है? लेफ्ट सब ट्री में से सबसे बड़ा एलिमेंट जो होगा, विच इज द बिगेस्ट एलिमेंट, 8. सो सिंपली यू हैव टू रिप्लेस विथ 8. अगर एग्जाम में कुछ नहीं कहा गया, आपके एग्जाम में अगर कुछ नहीं कहा गया, तो सिंपली राइट हैंड साइड से जो भी स्मॉलेस्ट एलिमेंट होगा वो आप क्या कर लेना? पिक कर लेना और रिप्लेस कर देना. दैट्स इट. रिप्लेस एंड डिलीट. क्लियर? सो फॉर डिलीटिंग 10 व्हाट आई डू? I pick the smallest element from the right subtree, that is 11. Simply I put it here. Clear? Now आपके दिमाग में ये आ रहा होगा, सर अगर 15 डिलीट करने का तो 15 डिलीट करने का तो राइट हैंड साइड पे आपके पास स्मॉलेस्ट एलिमेंट है क्या? 15 से स्मॉल नहीं, ऑल द स्मॉल एलिमेंट ऑन द राइट सबट्री, एक ही एलिमेंट है, that is 18. तो सिंपली यू हैव टू डिलीट दिस 15 एंड राइट इट डाउन 18. इज इट क्लियर? अगर गेट एग्जाम में फॉलो इन ऑर्डर सक्सेसर कहा गया तो राइट हैंड साइड से स्मॉलेस्ट एलिमेंट. अगर गेट के एग्जाम में इन ऑर्डर प्रीडिसेसर फॉलो करने कहा गया फॉर डिलीटिंग एन एलिमेंट, सो लेफ्ट हैंड साइड में से क्या करना है? एक ग्रेटेस्ट एलिमेंट उठा के रिप्लेस कर देना है. दैट्स इट. ओके, सो नाउ वी सॉल्व वन ऑफ द प्रॉब्लम that is asked in GTU examination. Okay, before that let's see one more example of case 3. Now suppose I have to delete 50 which has total 2 child, which comes under case 3. Okay, तो राइट हैंड साइड में सबसे स्मॉलेस्ट एलिमेंट कौन सा है? राइट हैंड साइड की सब ट्री में द स्मॉलेस्ट एलिमेंट इज 52. सो सिंपली आई हैव टू रिप्लेस 52 इंस्टेड ऑफ 50. इज इट क्लियर? Okay, so this is one of the example that is asked in examination, that so the resultant BST after applying following operation in sequence on the given tree. First you have to delete 8, then insert 9 and then delete 7. Simple. Delete 8 is in case 3. Total 3 cases are there. अगर वो लीफ नोड है लास्ट में तो उसे सिंपली डिलीट कर दो. क्लियर? अगर इंटरनल नोड है जिसका एक ही चाइल्ड है तो सिंपली उसका जो चाइल्ड होगा उसको ऊपर कर दो. एंड द केस 3 इज राइट हैंड साइड में चेक करो, जो भी स्मॉलेस्ट एलिमेंट होगा उससे रिप्लेस कर दो. क्लियर? सो इन द राइट सब ट्री विच इज द स्मॉलेस्ट एलिमेंट? द स्मॉलेस्ट एलिमेंट इज 10. सो वी हैव टू सिंपली रिप्लेस 8 with 10. So 10 is the lowest. We have to replace with 8. What is the resultant BST after deleting 8? This one. Simple ekdam. Okay, now insert 9. 9 is very simple. We have to follow the binary search tree rule. Okay, first we have to check with the root node, that is 10. So 9 is less than 10, so go here. Check with 3. 9 is greater than 3, go right hand side. 9 is greater than 6, go right hand side. Now 9 is greater than 7. Okay, so it will be at the right of the 7. Okay, So insertion is very simple. As you know how to construct the binary search tree, then insertion is very simple. Now the next one is delete 7. So here rule number or case number 2 will be applied. If it is an internal node, then what we do? We simply move up this particular node instead of 7. So we have to delete 7, and instead of 7 what we have to write? 9. Okay. So if we have to delete this 7, replace 7 with 9 and delete the 7. So this is how we have to delete an element from the binary search tree. Total 3 cases are there, you have to keep in your mind. तीनों 3 केस में फर्स्ट केस है, अगर वो लास्ट नोड है, दैट इज लीफ नोड है, डायरेक्टली डिलीट कर दो. इंटरनल नोड है तो उसके नीचे के जो भी नोड होंगे उसे क्या कर दो? अपवर्ड शिफ्ट कर दो, दैट्स इट. ओके, जिसके सिर्फ 1 चाइल्ड है. और थर्ड केस क्या हो सकता है? जिसके 2 चाइल्ड्स हो. 2 चाइल्ड्स हो तो क्या करना है? राइट हैंड साइड के जो सब ट्री होगी उसमें से मिनिमम वैल्यू पिक करके आपको क्या कर देना है? उस जगह पे प्लेस कर देना. क्लियर? सो दिस इज द आंसर. और अगर आपको 3 डिलीट करने कहा गया होता, ओके, इन दिस केस 3 डिलीट करने क्या होता, आप क्या करते? राइट हैंड सब ट्री में चेक करते विच आर द लेसर वैल्यू, दैट इज 4 को सिंपली आप रिप्लेस कर देते 3 से. I hope you understand how to construct a binary search tree, how to delete an element, that is most important. Okay, how to delete an element from the binary search tree. And if you have any query, please comment me. I will resolve that particular query. Okay, thank you.